Bias in AI models is a pressing issue that can have far-reaching implications across various industries, from criminal justice to healthcare and finance. AI systems, particularly those that rely on machine learning, are often trained on historical data that may reflect societal biases. As a result, these systems can unintentionally reinforce or even exacerbate these biases when making decisions or predictions. AI models learn from the data they are fed, and if that data is biased, the AI will likely perpetuate those biases in its output. Bias in AI can manifest in various ways, such as gender, racial, or socio-economic bias. For example, an AI model used in hiring decisions may favor male candidates over female candidates if the historical data shows a disproportionate number of men in leadership roles. Similarly, facial recognition systems have been found to have higher error rates when identifying people with darker skin tones because they were trained primarily on lighter-skinned individuals. In the criminal justice system, predictive policing tools that rely on biased crime data may disproportionately target certain racial or ethnic groups. Since these tools are trained on data that reflects historical policing patterns, which may include over-policing of minority communities, the AI system will continue to predict higher crime rates in those areas, reinforcing a cycle of discrimination. Bias in AI decisions not only perpetuates inequality, but also undermines the fairness and legitimacy of AI systems. When individuals are adversely affected by biased AI, it can erode trust in the technology and lead to broader societal harm. The risks of biased AI are significant and can lead to unfair outcomes, particularly for marginalized groups. In healthcare, biased AI models may result in misdiagnoses or inadequate treatment for certain populations. For instance, a model trained primarily on data from a specific demographic may not perform as well when diagnosing individuals from different racial or ethnic backgrounds, leading to unequal healthcare outcomes. In hiring and recruitment, biased AI can perpetuate existing gender or racial disparities by favoring candidates who fit certain profiles based on historical hiring practices. This can lead to a lack of diversity in the workforce and perpetuate systemic discrimination. In financial services, biased AI can impact credit scoring, loan approvals, and other financial decisions. If an AI model is trained on biased financial data, it may unfairly penalize individuals from certain demographic groups, making it harder for them to access credit or financial services. Controls to mitigate bias. To address the issue of bias in AI, several controls can be implemented. Bias auditing tools are one of the most effective methods for identifying and correcting biases in AI models. These tools analyze the data and the model's decisions to detect patterns of bias and provide recommendations for mitigating them. Another important control is the use of diverse training datasets. By ensuring that the data used to train AI models is representative of a wide range of demographic groups, developers can reduce the likelihood of bias in the model's predictions. This includes collecting data from different racial, ethnic, gender, and socioeconomic groups to ensure that the AI performs well across diverse populations. Fairness metrics can also be incorporated into the development process to measure the AI's performance across different demographic groups. These metrics help developers assess whether the AI is making fair and equitable decisions and allow for adjustments to be made when disparities are identified. Bias in AI models is a critical issue that has the potential to exacerbate inequality and undermine the fairness of AI systems. By understanding how bias in data leads to biased AI decisions and implementing controls such as bias auditing tools, diverse training datasets, and fairness metrics, developers can mitigate the risks and ensure that AI systems are more equitable and just in their outcomes.